I'm Paul. We're doing Leetcode must-know interview questions. Today's challenge, valid Sudoku. So we're out of the Leetcode, what was it, the sliding window category. And we're also out of, at least for now, the hard level problems. The last two problems we did were hard sliding window problems. And they were hard problems. The first one I think was harder than the second one because they were kind of similar, and so some of the things that I learned from doing the first one made it easier to do the second one. So let's see what we need to do here. Determine if a 9x9 Sudoku board, that's the input, is valid. Only the filled cells need to be validated according to the following rules. This will probably make more sense when we see an example. 1. Each row must contain the digits 1 to 9 without repetition. Without repetition is really the key here. Each column must contain the digits 1 to 9 without repetition. Each of the 9 3x3 sub-boxes of the grid must contain the digits 1 to 9 without repetition. This is not really an accurate description, in my opinion. I mean, there can't be any repetition, but each row doesn't have to contain all these digits because the input boards are, I think for the most part, incomplete boards. And we just have to validate them according to those rules. We don't have to solve it, and we don't even have to determine whether the grid can be solved. All right, a Sudoku board partially filled could be valid, but it's not necessarily solvable. So I can tell you that this example is a valid Sudoku board because there are no repetitions in rows or columns or subgrids. One more thing to note here is that while it looks like in this example that we're dealing with string arrays, we are actually dealing with character arrays. So, all right, so we get in a character array and we determine whether that is a valid Sudoku board. In other words, whether the board has no repetition of numbers in rows or columns or subgrids. All right, board length 9. Okay, so the way to do this, I mean, it's a matrix. It's a matrix problem, and so it's an O of n squared algorithm, but the inputs are just like 9x9 boards, so it's not really a problem. What we can do is we can write a nested loop. It's going to process each cell in the input matrix, starting with the top left and going in row first order. And so we'll look at the number in the cell and we'll check and see, is this number duplicated in the current row? Is this number duplicated in the current column? Is this number duplicated in the current subgrid? And if the answer is no, then we'll go on to the next number. If we find that a number is duplicated, we just stop at that point and return false. If we can get through the whole grid without finding any duplicates, then we return true. Now, the way I described it, we're not going to do it exactly the way I described it, because, I mean, the runtime is just going to be off the charts. If we look at, say, the first number and then we look at all the subsequent numbers in the row for a duplicate, and then we look at all the subsequent numbers in the column for a duplicate, and then we look at all the subsequent numbers in the subgrid for the duplicate, Let's say we don't find any. Then we go to the second number and we do it again. Look at all the subsequent numbers in the row, column, subgrid. I mean, the runtime is going to be off the charts. So we're going to add a little nuance to it. And actually, let me stop here and introduce one concept that we're going to need. Okay, one concept I want to introduce, if you're not already familiar with it, is the concept of subgrids in a Sudoku board. So the Sudoku board is 9 by 9. It has 9 subgrids, and those are 3 by 3 sections. So it looks like this, and we're going to index them like this. So the top left subgrid is subgrid 0. Move to the right is 1, 2, and so on, 0 through 8. And one thing that we're going to need to make this work is that we're going to need a computation that can convert a cell's row and column index to a subgrid index to indicate what subgrid is a cell in given its row and column. And we can do that. I'm not going to do a proof of it, but you can verify for yourself that it works. All right, so we've introduced subgrids. Is there anything else? I think we can probably get started with the code. Okay, the example here, example 1, which I probably should have shown when I was talking about subgrids, but you can see the subgrids pretty clearly in that example, the way it's drawn, because they have bold lines separating the subgrids. So for now, I'm going to move this over so we have more room to be able to see code. I'm going to move this over a little bit as well. And all right, we are going to use 3 Boolean matrices, one for the rows, one for the columns, one for the subgrids. So let's code them first, and then we'll talk about how are we going to use them. I don't need that. These are matrices. We'll call one rows, and that'll be a Boolean array. New Boolean. It'll be 9 by 9. All right. And let me copy that a couple more times. The second one we'll call columns, and the third one we'll call subgrids. All right. Now, these numbers, 9 by 9, all right, the first index is the index of the row or column or subgrid. The second index is a number. In Sudoku, we can have numbers from 1 to 9. Now, JavaScript has zero-based indexing, so even though the second index represents a number, we're going to have to subtract 1 from the number in order to be able to make it work with these matrices. So the second index is a number. It's going to be 0 to 8. We're going to subtract 1 from each number before we put it into the matrix. Okay. Yeah, and I think we can start the loop. We're going to do a nested loop here. So for I equals 0, I is less than 9, I plus plus. Actually, we can probably copy that. For int j equals 0, where'd it go? J is less than 9, and J plus plus. All right, first thing, if, now you can see, let me move back over a little bit. The character inputs here are either integers or dots, and if they're dots, we don't care. We don't need to do anything with the dots. So let's say, well, actually, first of all, we got to get the character. Current char equals, the input is called board, and we're going to get I, J. All right, so that's the current character. If the current character equals a dot, then we don't care. Continue. Just go on, continue. Just go on to the next one. All right. We need to convert the character to a number because we're going to use it as an index into those Boolean matrices. So let's do that. Let's say int number equals current char minus a 0 character. You've probably seen this technique before, but characters are really just numbers. I mean, they're character codes, and Java handles the conversion for us. So if we subtract the 0 character from a character representing a digit, then we're going to get the numeric value of that character. But again, in order to make it work in a matrix, we're going to have to deduct or subtract 1. All right. So we have enough to be able to work with the rows matrix and the columns matrix, but not the subgrids matrix. We have to convert the row and column, which in this case we're calling I and J. We have to convert that to a subgrid index. So let's call it SG subgrid index equals I divided by 3. That's an integer division. Times 3 plus J, again, integer division, 3. You can take my word that that will work, or you can, pick some, a representative sample of, row and column combinations and go through the computation and verify that it does in fact work. All right. Now, we're checking for duplicates. So if rows, that's the index and then the number, and if that is true, and the first time we see the number, it won't be true. It'll be true the second time we see the number. So we're not going to search for duplicates. We're just going to mark that we've seen a number, and the second time we see it, we'll identify it as a duplicate. And actually, let me copy that. If rows I number, or, whoops, no. Oh, sorry, it's capitalized. Okay, or columns J number or subgrids SG index. number. What is that? Sib grids? No. Subgrids. Subgrids, SG index, number. All right. If any of those are true, it means we've seen the number before. And it's not a valid matrix because of the duplication. All right. If we haven't seen the number before, let me copy that. It might save some typing. If we haven't seen it before, then we will say rows I number equals true. We've seen it. Columns J number equals true. We've seen it. Subgrids SG index number equals true. All right. Close that. That's the inner loop. Okay. Close. You know what? This is probably in here. Hang on. That closes the inner loop. That's already there. All right. So that closes the outer loop. If we get through that whole thing and we haven't returned false, then it is a valid Sudoku board. Oops, not false. Return true. All right, we need one more. One more here. All right, let's try it. Run. Compile error. Not a statement. Extra parentheses in there that we don't need. All right. Try it again. All right. Basic test cases work. Frame and submit. Make that a little bit wider. All right, that is accepted. 2 milliseconds. 2 milliseconds. A lot of people got 1 millisecond. Oh, oh no, that's not the memory. Okay. So that's the solution. Just iterate through the Sudoku board, one cell at a time. When we have seen a number in a row or a column or a subgrid, mark it so that if we see it again, we can return false. If we get through the whole matrix, we haven't returned false, then it's a good it's a good board. All right, that's it. Feel free to like, subscribe, and see you next time.